Hey guys, from now on I'm gonna make a series which contains the videos of nitrogen family. So this is a part 1 of nitrogen family, and today we'll be discussing some points about nitrogen family. Nitrogen family is important for boards as well as JEE main and advanced and NEET too. So not only this competitive exams but for many Olympiad exams too. And P block is a very important chapter for inorganic chemistry, and therefore you need to revise this P block thoroughly. And so it's very important to make short notes of this nitrogen family and oxygen family of P block. And welcome to the part 1 of nitrogen family. So nitrogen family, so we'll be discussing some points about nitrogen family, some very important points in this video, and in the next video we'll be discussing about the compounds formed involving the nitrogen and phosphorus. So today, nitrogen family. So nitrogen family is group 15 and it belongs to the P block. So nitrogen family electronic configuration is NS2NP3. Okay, so in nitrogen family we have 5 elements, and these are nitrogen, phosphorus, arsenic, antimony and bismuth. So if we observe their atomic numbers, we can actually see a pattern. So 7, remember it as it is 7, and we have 15 here. So this is 33, this is 51 and this is 83. So 15 and 51, these are like reverse, right? 1 5 5 1. So remember it like that. And here you have 33 and 83. So here you have 50, right? 33 plus 50 you get 83. Actually 51, but consider it as 50 just as a trick. So 7, 15, 33, 51 and 83. So it's very simple if you remember it like that, or else you can actually form your own tricks. And the next thing is their atomic masses. Remember their atomic masses, because when you solve things in the physical chemistry, these are important. Although they give atomic masses in the paper itself, so no need to worry. And we have the configuration now as I discussed, NS2NP3. So nitrogen we have 2s2 2p3, phosphorus we have 3s2 3p3, arsenic 3d10, okay 3d10, 4s2 4p3 and 5s2 5p3, 6s2 and 6p3. So that is general electronic configuration of nitrogen family is NS2NP3 group 15. Okay, and here you have a very important thing, that is nitrogen and phosphorus are non-metals. Arsenic and antimony are metalloids, and bismuth is a typical metal. So it means the metallic character increases down the group, okay, from nitrogen to bismuth. And this is electronegativity. It's not really necessary to important them, but I actually made it in my notes because it may be useful for my further studies. Then you have physical properties. All these are polyatomic. Dinitrogen is a diatomic gas, while all others are solid at room temperature. So only nitrogen is gas at room temperature in group 15 elements, and all others are solids. So metallic character increases down the group, and the BP increases from top to bottom. BP is boiling point and it increases from top to bottom, but MP melting point increases up to arsenic and then decreases up to bismuth due to the fully filled d orbital, okay, and half filled f orbital. Then except nitrogen, all the elements show allotropes. Allotropy, okay. Allotropy is existing in different forms, okay. Single element existing in different forms, like for phosphorus we have P4, P8 and so on, right? That is allotropy. And except nitrogen, all the group 15 elements exhibit the allotropy. Phosphorus, arsenic, antimony and bismuth, all these elements except nitrogen exhibit the allotropy. So but we'll be only discussing the allotropy of phosphorus in our 12th class, because that is good enough for us, because we have many elements to deal with and we can't just sink into all these, and it will take a whole year to discuss all these things. So we'll be discussing mainly only about nitrogen and phosphorus in this nitrogen family. All these 3 elements are like, they are too complex for our grade or class we say. Therefore, we'll be only discussing nitrogen and phosphorus clearly in this chapter, nitrogen family. Okay, and preparation and properties of elements. So here, as I said, we only discuss about nitrogen and phosphorus. So first, preparation of nitrogen. Nitrogen exists as dinitrogen in the nature. So it is generally N2. So lab preparation and industrial preparation. First, lab preparation. First, ammonium chloride is added to NaNO2 and we get NH4NO2 plus NaCl, and we take NH4NO2, and when we heat it we get N2 gas. N2 gas is liberated, we'll be collecting it, and this is how we get nitrogen by lab preparation. And then oxidizing NH3 with calcium hypochloride, bromine water or CuO. So we have this is NH3, we are oxidizing it with bromine water, we are oxidizing with CuO, with calcium hypochlorite, and with NaOCl. So we get N2 everywhere. So this is lab preparation, you can note down. And then industrial preparation. Industrial preparation we have from liquefied air by fractional distillation. We already know that in the Earth's atmosphere, the nitrogen constitutes around 78%. 78% is more, it's really a huge amount. So when we actually take the air, like if we take a small portion of air in the atmosphere, and when we actually liquefy it by fractional distillation, we get N2 and O2, because O2 is also in large amount, it is 21%, whereas nitrogen is 78%, and we get this boiling points are nearly almost same, so we can actually separate them by using fractional columns, and here you go, we get industrial preparation. So industrial preparation is collecting nitrogen in large amounts. So how can we collect nitrogen in large amounts? If we do it in lab, we only get small amount of nitrogen, because we'll be doing with test tubes, they are so like small things, right? Yeah, whereas in industrial preparation we take some part of the air, like we collect some air, we liquefy it, and then we separate nitrogen and oxygen by fractional distillation. And the second thing is from producer gas. What is producer gas? Producer gas is a mixture of CO and N2, carbon monoxide and nitrogen. So we should take the producer gas. When we heat the producer gas by passing through CuO, then we get N2 gas. So it remains in the gas cylinders, we can collect it, and this is how we obtain the N2 gas in industrial methods. So lab preparation, in lab preparation, first thing we do, we add up these both compounds, we get NH4NO2. When we heat NH4NO2, we get N2. This is one lab preparation. Then the next thing is oxidizing NH3 with calcium hypochlorite, bromine water or CuO. And in industrial preparation, we do what? We collect some part of the air, we liquefy it, and we separate N2 and O2 by fractional means. And then second one is from producer gas from furnaces. And the C, the last one, very pure nitrogen. We get pure nitrogen too. How? BaN3 taken twice is heated and we get Ba plus 3Na2, or sodium azide NaN3. Sodium azide is NaN3, and when we heat it at 300 degrees Celsius, thermal decomposition we say, when we thermally decompose sodium azide, we get N2 gas. Okay, so this is how we obtain very pure nitrogen. So there are three ways for the preparation of nitrogen, and these are very important in the view of JEE main and advanced. So please remember them. Have a look at them, not just having a look, learn them before you go to the exam. So because this in organic chemistry is all how we memorize them, that's why you need to have a good look at it before the exam. Okay, and the next thing we have is phosphorus. I already told you that phosphorus and nitrogen are very important elements in group 15 in the view of JEE mains and advanced. So not we should totally focus on these two elements in group 15, and other elements just can be neglected for now. And when we have just discussed already nitrogen. lab preparation, industrial preparation, and very pure nitrogen. And now we'll be discussing phosphorus. We obtain phosphorus by reduction of calcium phosphate with coke in electric furnace at 1400 to 1500 degrees Celsius. And we use sand. Sand is added to remove the calcium as fluid slag. And then we get Ca3PO4 taken twice plus 6SiO2. We get 6CaSiO3 plus P4O10. And we collect P4O10 from this reaction, and P4O10 is added to 10C and we get P4 plus 10CO. This is how we prepare phosphorus. This reaction is a bit complex, just remember it. And this is how we obtain phosphorus. So now, as we discuss the preparation of this both important elements, nitrogen and phosphorus, now let's move further. Let's move to the properties of nitrogen and oxygen. Nitrogen exists as N2 in the nature and phosphorus as P4, white phosphorus, and nitrogen. So nitrogen and phosphorus, these are the physical properties. Nitrogen's physical properties: this is colorless, odorless and tasteless gas. Phosphorus is waxy, solid, soft and reactive, and it is solid at room temperature. This is gas at room temperature, diamagnetic gas, solid at room temperature. Earlier we have discussed that all the group 15 elements are solid at room temperature. The exemption is only for nitrogen. Nitrogen is only the gas at room temperature in group 15 elements. And this is diamagnetic gas. This is solid at room temperature. It is insoluble in water. It is neither combustible nor a supporter of combustion. And phosphorus, it reacts with moisture and gives out light. So chemiluminescence. This is inert at room temperature. Nitrogen is inert at room temperature. And phosphorus, it ignites spontaneously in air at 35 degrees Celsius especially, and stored underwater to avoid its reaction. So it is highly reactive. That's why it is stored underwater, because it's highly reactive with air. And nitrogen forms only one compound at room, it is inert at room temperature. It almost behaves as a noble gas. That's why it doesn't react as much as other elements like phosphorus and other group 15 elements. It only forms a single compound, that is Li3N. Okay. And phosphorus, it exists as P4 tetrahedral molecule, and it ignites spontaneously in air. Okay. Above 800 degrees Celsius, P4 dissociates to P2 molecule. So these are the physical properties of N2 and P4. You need to remember. These are actually easy if compared to the preparation, so you can easily remember them. And another important thing is their occurrence. Nitrogen is 78% of Earth's atmosphere. We have read it since our childhood, and it is very easy to remember. And it mostly exists in our body too, in form of amino acids and proteins. And phosphorus is 60% of bones and teeth are Ca3PO4 taken twice, or this one. Okay. And phosphorus is it's mostly in our bones and teeth, as well as DNA and RNA in our body. So it is 60% of our bones and teeth. So this is occurrence, and these are physical properties, and we have already discussed preparation. And this is all about our first video. So in the next video we'll be discussing general trends and chemical properties of group 15. And once I'll revise you everything what we have discussed in this video. First thing first, we'll discuss the elements which are in group 15: nitrogen, phosphorus, arsenic, antimony and bismuth. And then we discussed all these atomic number, atomic mass, general electronic configuration, physical properties, preparation of nitrogen and phosphorus, the physical properties of nitrogen and phosphorus, and their occurrence. So this first video is very simple, and the actual game starts from the second video, because in second video we'll be discussing the general trends and chemical properties of the elements, as well as compounds of nitrogen and phosphorus. And then we'll move to oxygen family. We'll be completing P block very fast, and please prepare the short notes of all the things told in this video. So I already wrote the points clearly in this book, and I showed you point to point. So pause the video and copy everything and prepare short notes. And I would suggest you to actually go through NCERT once, because NCERT is the heart of the chemistry. And that's all is what I want to tell, and meet you in the next video. See you in the next video with a very complicated topic than the topic now, that is general trends and chemical properties as well as the compounds of nitrogen and phosphorus. Okay, bye. And we'll be also discussing allotropes of phosphorus. They are very important in the view of JEE mains in advance. Okay, bye. And your doubts will be clarified in the comment section itself. And if your doubt is like highly complicated, or if it requires more explanation, then I'll be looking at all those comments today and tomorrow, and I'll add the answers in the next video. We'll also solve the previous year questions. And thank you.